Welcome to Newton's method. So the goal here is to approximate roots of functions for roots that are difficult to find, right? So the goal is to approximate the root of a function. And hopefully faster than using the bisection method. Root or roots of a function, hopefully faster than using the bisection method. So basically the idea is, let's go ahead and just draw a quick graph. So the idea is we pick a point near our root, right? So this is step one, as we're going to pick a point near the root. And then we will use the tangent line approximation. So if we draw our tangent line approximation, so we're going to use the tangent line, refine the tangent line approximation. We're going to find the root of that line. So we'll find where that line crosses 0. And now we'll start the process over again using that as our new x value. So we will then use that as our new x value and pick the point corresponding to that x value and then do the tangent line approximation, find where that hits the x-axis, go through. Right, so now we're going to find the point at that x value. And then do the tangent line approximation, keep going. Right? So we just kind of keep looping back around. So if I zoomed in, right, I could now do our tangent line approximation at this value. That now gives me a new point. And then I could, again, figure out where that is on the graph, do the tangent line approximation, and it hopefully will get us closer and closer and closer into our actual root. Right, so if I zoom back out all the way, you can see those points going in closer and closer and closer into where the line crosses the x-axis. So the calculations, basically we need to figure out what is the formula for where the tangent line approximation crosses the x-axis. So essentially, we need, oops, let me use a thicker pen. So we need to know the formula for where the tangent line approximation crosses the x-axis. So since we are going to have a series of points on our graph, I'm going to label these points x sub n, and n will just be the numbers, counting numbers. So first, let's find the tangent line. At x sub n. So again, the slope is just the derivative of the function at x sub n. And the point is just x sub n, and then whatever the function value is at x sub n. And so we have the equation or the line. We would have y is equal to our slope f prime of x sub n times x minus x sub n, and then plus f of x sub n. And now we're going to find where that crosses the x-axis. Find the x-intercept. Of the tangent line. So we have then 0 equals f prime of x sub n times x minus x sub n plus f of x sub n. If we rearrange this, if we subtract f of x sub n from both sides, we are looking at negative f of x sub n is equal to f prime evaluated at x sub n times x minus x sub n. Unwrapping, working our way in, we could go ahead and divide by f prime of x sub n. And we now have negative f of x sub n divided by f prime of x sub n equal to, I just realized I lost a parenthesis previously. Here we go. This is equal to x minus x sub n. If we add x sub n to both sides, we wind up getting that x is equal to x sub n minus f of x sub n divided by f prime of x sub n. So this is the x-intercept of the tangent line. And we're going to set this as the next x value in our algorithm. So this is the next So this will be the next x value in the algorithm. So what our algorithm will be, so Newton's method what we will do is we will pick a point or pick an X value near the root. We'll go ahead and call this X value, you can either call it X0 or X1. So we'll go ahead and call it X1. Then to find X sub n plus 1, we'll do X sub n plus 1 is equal to the formula we just got. So it's X sub n minus f evaluated at X sub n divided by the derivative of f evaluated at X sub n. And then we will stop when we get two X values in a row that agree on enough decimals to satisfy us. So when we get two X values in a row that agree on enough decimal places to satisfy us. So in the next video, we'll see a little more what I mean by this process. I'll go ahead and do a couple of examples for you of just how this process works. But again, it is all just based off of that picture I drew, right? If we use a tangent line approximation, that gets us in a little closer to the root, at least that's the goal. And then we do another tangent line approximation that gets us in a little closer to the root, do another tangent line approximation, etc. All right, so this is Newton's method. This is actually largely what calculators do to approximate roots, is they essentially do run through Newton's method.